Hi everyone, I'm Pelio from Monash University, Australia. Today I will present our paper automatically detecting API-induced compatibility issues in Android apps, a comparative analysis. Today's presentation contains 6 sections. I will begin with introduction and then motivation, status quo understanding, replicability study, comparison study, and finally ends up with implications. Fragmentation has been a severe problem for the Android ecosystem for years. This refers to the fact that there are a massive number of Android devices manufactured by different companies running different operating systems, including both different official releases and customized ones. This introduces inconsistencies in that certain apps can only function properly on devices running certain Android versions with certain device features, such as the example, the Android apps could only work properly on device B with OS version V1, but cannot work properly on device A with the same OS version V1 and the device B with a different OS version V2. This type of crash on different OS versions or different devices is what so-called compatibility issues. To address these issues, there has been a great deal of research in analyzing the compatibility issues of Android apps. In the area of static analysis, researchers have proposed various automated approaches to pinpoint one of the most common issues, the API-induced compatibility issue. However, it is still unclear what the status quo of Android app compatibility analysis is, what their strengths and weaknesses are, and to what extent they are able to identify all the possible incompatibility issues. Furthermore, it's also unknown if we could reproduce their experimental results and how well do the state-of-the-art tools compare with each other in terms of detecting compatibility issues. Now, let's begin with the status quo understanding. We performed a systematic literature review to understand the status quo about the app compatibility analysis. The figure shows the working process of our literature review. We resort to a set of keywords, 2 groups, to search for relevant publications in popular repositories and core A-star ranked venues listed in the table. In total, we have 19 venues, 5 journals, and 14 conferences, applying the keywords to search for relevant publications. Finally, we targeted 9 relevant papers listed in the table, which involves 7 artifacts, and there are 2 papers published first on conferences, and then extended to journal papers. We carefully read the full papers to understand how each of their automated issue detection approaches are implemented. The common working process could be split into 2 steps, including data-driven approach for harvesting incompatible APIs and program analysis for detecting unknown compatibility issues. The output of the first step will be a list of incompatible APIs, which will take as input to the second step. The table shows the ability of the tools to harvest incompatible APIs and detect issues. Since Pivot was developed for incompatible APIs harvesting, we excluded in the following analysis. Furthermore, we categorized the incompatible APIs into 5 types: evolution-induced, including methods and fields, that is, the evolution of the operating system, the same app on the same device but could not run successfully on different OS versions, and device-specific, including methods and fields. That is the same app on the same Android version but cannot run successfully on different devices, and the override callback methods due to the evolution of the Android framework. Some callbacks may have been alerted. The callback methods defined by the framework that could be explicitly overwritten by client Android developers, but their execution will be triggered by the framework. We also summarized the detection of different types of issues with regard to the proposed artifacts. The table shows that most of the tools are developed for detecting compatibility issues induced by the method's evolution of the Android system. For the field evolution-induced compatibility issues, Asset and ICT API Finder have mentioned the issue in the paper, but not in details. In column 7 of the table, we also summarize whether the proposed approach involves a systematic approach to harvest incompatible APIs or not. The last column further highlights whether the proposed approach itself is fully automated or not. An automated approach should not involve any manual efforts that may pose difficulties to replicate. With the detection artifacts, can we still replicate them? Which is our second research question. Since ACID and ACRWL cannot be exceeded successfully, we finally selected 4 detection tools: CIDR, SEED, ICT API Finder, and Fig Finder. We intend to run the tools against their original datasets. Therefore, we have eventually selected 45 apps, 20 for CIDR, 7 for SEED, 8 for ICT API Finder, and 30 for Fig Finder. With the dataset, we do our replication. CIDR and SEED do have exactly the same outputs on the original Android apps, while Fig Finder and ICT API Finder have some different outputs regards their original experimental apps, which are mainly caused by slightly updates of the tools or the evolution of the evaluated apps. Then, we aim to empirically compare the state-of-the-art tools targeting the detection of compatibility issues in Android apps. That is our comparison study. We selected the same 4 detection tools against 2 datasets. The first one contains 65 Android apps, and the second one contains 645 Android apps from the public dataset Android Compass. The experiments on 2 datasets show that SEED is able to yield more compatibility issues than the other tools, followed by ICT API Finder and then Fig Finder. Their results are, however, not overlapped, suggesting the existing tools are complementary to each other, and yet still have limitations to achieve sound compatibility issue detection. Furthermore, the fact that SEED and ICT API Finder can yield significantly more results than Fig Finder and CIDR suggests that it is essential to leverage systematic approaches to mine incompatible APIs so as to support the detection of compatibility issues. With the replication study, we can get some take-home messages. First, continuous improvement to adapt to the fast evolution of the mobile ecosystem. Second, extracting complete incompatible APIs. Third, integrating dynamic testing to verify compatibility issues. Fourth, characterizing semantic changing incompatible APIs. That's all. Thanks for your attending. Thank you.